So welcome back. Now let's look at question 2 from the paper GCSE 1F, question number 2. And now we are supposed to derive the equations of motions. The first equation is what you can see here. We tried to show how we got the formula for kinetic energy as it is given as a half mv squared. So now let's look at how you can derive the third equation. Like from the first, according to the equation, you are supposed to derive the first equation of motion, the second equation of motion, and the third equation of motion. Okay, so let's do that. So if I take this up a bit, so let's see what we can do in terms of deriving this equation. Okay, so what are the initial conditions that we need in terms of deriving this equation of motions? So topic here, or what you are supposed to do, is to derive. So this is derivation of equations. So this is derivation of equations of motion. So we will look at how we can be able to derive this, and I will go with you slowly. Okay, so the initial velocity in this case will be given as u, our initial velocity. So this u represents the initial velocity. Then we have the final velocity. In this case, it will be given as v. To represent final velocity. Final velocity. Okay, so now acceleration will be given as a. So a here will represent acceleration. We have t. T will represent the time taken. So t in this case is simply time. These are the initials. Then s, in this case, this will be displacement. S is going to be displacement among others. So the first equation of motion is given as a, acceleration, is nothing but the change in velocity with respect to time. And the change in velocity in respect to time is given as the final velocity minus the initial velocity, all this divided by the time taken. Now, if I cross multiply, I will simply have v minus u that we have on the numerator to be equal to at. That is, if you try to cross multiply time taken in respect to the acceleration. This is time taken. So v minus u, which is the change in velocity, final velocity minus initial velocity, will give you at, acceleration with time. By simplification, if I make v the subject, then I will have v is equal to u, because when I take negative u to this side, it becomes positive. So this is u plus at. So this is the first equation of motion. This is the first equation of motion, which is what you are expected to prove first equation of motion. You are supposed to show up to the third equation of motion. So let's go ahead and do that. The second equation of motion is talking about average velocity. So average velocity, if we know that the change in velocity is v minus u in respect to time taken, so the average velocity will be given as s to be equal to, in this case we add them, u plus v, right? And we take the average, divide by 2, then multiply this by the time that it takes to cover the distance. So, and I will now substitute equation 1. If I substitute equation 1, we got v, it is here, which is equal to u plus at. If I put this in respect to v, where you see v, you simply put this equation 1. So I will have s is simply going to be ut, because we have t here, so it is ut plus a half at squared. So this is the second equation of motion. The third equation of motion is simply from this second equation of motion, like we have seen. So for us to derive the third equation, we simply need to start from the second equation. We want to now substitute the first equation. We know that t, like we have said, t is going to be equal to v minus u divided by a, or a is v minus u divided by t, just like we have it here from the first equation of motion. What we will have becomes the second term is going to be, we have a half ut plus a half at squared. So we are going to have a half a, multiply this by, just a minute, so I multiply this by v minus u, there is squared here, so we can square this, divide this, if I divide this by a squared, so I will simply get v minus u squared over 2a. So we can get a common denominator. Let's try to take this up a bit. If I get a common denominator, I will simply have s to be equal to 2u, then v minus u plus v minus u squared, divide all this by 2a. If I expand the numerator, I will get 2u v minus u. So this becomes 2u times v gives us 2uv minus 2u squared. So this gives us v minus u squared to be equal to v squared minus 2uv plus u squared. We can try to work on this side. So let me use the red pen and try to do that. So from here now we can add the two values. We will simply get 2uv minus 2uv minus 2u squared from here plus v squared minus 2uv plus u squared. So this will give us 2uv minus 2uv will cancel out because you have 2uv minus 2uv. So we are going to simply have v squared minus u squared. So S is simply v squared minus u squared. Divide this by 2a. Multiply both sides by 2a. This gives us 2as. This will be equals to v squared minus u squared. If I rearrange and make v squared the subject, since we are looking for this velocity or the change in velocity, it becomes v squared is equal to u squared minus 2as. This is the third equation of motion. And this is what is required in the paper that you guys were given. All the best.